Let's try putting the...
So those of you who looked at the video last week will recognise the battery on the left, and we've got a reasonable car battery which measured 12.5 volts. We did try and take it down a little bit earlier by putting a couple of bulbs in parallel across it.
Let's try another meter. That one seems a little bit...
So that meter was no good. We're trying with the
just trying another
meter now. Yeah. So yeah, we didn't take it down too much with those bulbs, did we?
Yeah.
So it's more or less 12.4, 12.5 what we got earlier. Yeah.
So we've not really achieved anything with that one yet.
So yeah. I think this just shows it's in operation really, because the battery's more or less fully charged, isn't it?
Yeah.
So perhaps at some point we can see it being charged up from... how low would the voltage be? Would it go down to 0 if it was fully discharged?
I wouldn't have thought so. Well, obviously we could take it down to 0, but it would probably destroy the battery.
Right.
I think if we took it down below probably 10 volts, that's as far really that we would want to take it, because you then start to really do damage to the battery if you let go lower than that.
So we'll just have a look at that, and I'll just give a quick glimpse in the corner of your Mark III, which is starting to take shape there.
Yeah.
And I think it just goes to show...
well, if I bring that one down, we can have a look at the difference on that. What we're doing there is we've put in, obviously, more magnets, much better bearings, a bigger wheel, and also a little pulley stroke flywheel device there that I intend to try driving things off to see if we can get mechanical power as well as an output of electrical power.
Those magnets you showed me the other week, and I couldn't believe how strong they were.
Yeah, incredibly strong. I searched the internet to find out the most powerful magnets money could buy, and these turned out to be the ones, and the name of which totally escapes me.
And you showed me an extra component you were going to build into this.
Yeah.
Was it a rectifier you called it?
It was basically it's a bridge rectifier. What I'm going to try is to rectify the charging current and feed back a percentage of it into the primary battery to maintain the charge in the primary battery, to drive the Bedina machine whilst charging the secondary battery, and thus obviously give us as much running time as feasibly possible. The ultimate goal would be to run it and just let it run literally forever. Whether that's possible or not, we shall see.
I seem to recall that just looking at these, I mentioned on the blog today that people interested in this sort of technology are often called sort of perpetual motion luminaires, and I don't think anyone is complaining. He's actually saying this can run forever because parts wear out.
That's right.
So we make no claim to that perpetual motion machine, just that the ultimate aim of people interested in this, and I think John Bedini has showed it, to my satisfaction, is you can get more energy from the vacuum than you're actually putting into the circuit itself.
Yeah. What we need to determine though is how how we actually test that. We've done tests to monitor current in to the circuit and current out, and voltage in and voltage out, but that hasn't given us any conclusive proof whether the machine is running over unity or not.
So whilst we sort of believe we believe John Bedini is definitely for real, as far as our own little laboratory situation is concerned so far, it's early days for us, and we're really just learning.
Yeah, very much so.